Hi, everybody. So, time to start, apparently, so let's go. So we're going to talk about the art of PostgreSQL. The idea of this presentation is that it's mostly oriented for application developers. So who are you guys actually writing code for an application and using PostgreSQL? Yeah, some of you. Well, the other, don't be too sad about it. You will have some good content too. So. I've been a contributor for PostgreSQL for a long time now, like last century, working at Citus Data, and we got acquired by Microsoft. So nowadays it's Azure database for PostgreSQL hyperscale Citus, something like that. One of the projects I'm working on currently is named PG Auto Failover. And the idea is just exactly as the name says. In PostgreSQL, we tend to like boring names, right? So you read the name and you know what it is about, usually. And so it's business continuity, like it's automating the failover. So that's all about it. So it's on GitHub. It's a completely open source. You can open issues. You can send bug fixes if you want to, even new features if you fancy that. So go have a look. It's a project we did to simplify setting up HA for PostgreSQL. Another project I've been working on a lot the past years is a migration project for going from something else to PostgreSQL. The idea is that you don't have an excuse anymore to be using, for example, MySQL. Just use PostgreSQL instead. It's much better. But it's not always easy to implement that. And so with pgloader in a single command line, you give it the source connection string and the target connection string. The target should be PostgreSQL. And then it's going to read all the catalogs from the source database, decide what are the table, the columns, the attributes, the types, do the type mapping for you, and then load the data, and then create the indexes in parallel, and et cetera, et cetera. So it's one command line, and then your database is running on PostgreSQL now. So no excuse, just do it. It supports MySQL, SQLite, SQL Server, and some other input kinds. Another project I've been working on is this book, The Art of PostgreSQL. We have some copies left, maybe the last one or something like that at the booth. So if you're interested, show up there later. And the slides that we're going to go through are mostly extracted from the book. Okay, so it's kind of the same content. So let's get started now. So the first thing is that for me is important as an application developer is why are you using PostgreSQL? So often when you ask that question, I used to be a consultant before, and when you get around this question, lots of them they don't really know why. It's just that it's in the stack, it's been deployed already, they joined the project, and they have to use it. Some other, they're like, oh, I know why. It's because it's solving this problem that is quite hard to solve for the application, and we are using PostgreSQL to do that. But often enough, I heard that PostgreSQL is used to solve storage, which is surprisingly surprising as an answer because it's so wrong. It's not true. Like storage in the 60s, it was easy because at the time, with the computer we had, if you would unplug it from the power socket, then anything that was in memory would stay exactly the way it was. And you could replug it like a couple of weeks later, and it would be exactly like it was two weeks before. And in the 70s, we switched to other technology where it was not true anymore. But being able to serialize something that you had in memory to disk has never been such a problem in computing science. It's easy to do. Everybody knows how to do it. You don't need PostgreSQL to do that. If you're a Java shop, you just serialize your object in XML and read them back, and that's it. So if storage is the problem, you go use, for example, on the cloud, blob storage from Azure, or maybe S3 from AWS or something else. So that's storage. So PostgreSQL is not about storage. PostgreSQL is about concurrency and isolation. The idea is that what happens when you have more than one person trying to do the same thing, like two updates concurrently. Yeah, and the image is obviously the difference between theory and practice. So in theory, it's the same, but not in practice. So the main thing around concurrency and isolation within the context of database, like relational database management systems, RDBMS, is that we say that we provide ACID guarantees. So I guess everybody knows what ACID is. It looks a little boring, yeah, but let's see a little more about that. Atomic, basically it means that if you have many things to do in the same transaction and something goes wrong, you can roll back. And if you did 2 inserts and 1 update and then you roll back, then everything is cancelled. You don't have like one of the inserts went through but not the other one, and no, your database doesn't make sense anymore. So that's pretty cool. But usually we don't type in rollback. Well, sometimes we do when we are testing interactively. But in the application, have you ever implemented a transaction that will do a rollback in your application? Maybe not. What happens is maybe the file system is full. I know it's 2019, but we still have that problem in production sometimes. So file system is full. What's next? Well, with an atomic system, the transaction is rolled back and never happened. That's it. So you're safe. Where PostgreSQL does something that almost no other system is able to do is it supports transactions for DDLs. So if you have an application script to migrate or move from one version to the next version of the schema, you add some columns, a new table, maybe a new index, something like that. Well, then what happens if file system is full in the middle of the script? If you're not using PostgreSQL, then you had version 1 in production. The script was to go from version 1 to version 2, and it failed in the middle. So now you have a version that nobody ever saw nowhere. No developer ever saw that version that is now in production if you don't have transactions for DDLs. With PostgreSQL, file system is full. Yeah, OK, roll back. You're still on version 1. Don't deploy the app yet. That's it. Simple. Done. So that's one of the reasons why you would use PostgreSQL, of course. The C of ACID, it means consistency. Consistent means there are some business rules that you know about and that you can share with PostgreSQL. You can explain to PostgreSQL, here is what's important for me to keep in mind for the whole data set that we are going to manage. And you can have PostgreSQL implement those guarantees for you. So the first step for the consistency is the schema and the data types. So here it's a very simple table with 2 columns, but anything that goes into those columns, here, for example, the ID is an integer. So I like sometimes to say bad things about other products. If you use MySQL and you have an integer columns and you insert into it the string banana, then it will happily take it, and if you select from it, it's going to say 0, but no errors whatsoever. It's happy to work with that. So maybe it's not consistent, I don't know. With PostgreSQL, we don't do that. So if you try to insert banana into an integer column, PostgreSQL will tell you, hey, I don't know what that is, but it doesn't fit your model. Please be careful. And then we have constraints like check, not null, foreign key, primary key, relations. And we'll get back to that. Relations are the central concept of SQL, basically. And some people think it's because we have foreign keys, but it's not true. A relation is just a mathematical concept where you have a set of elements that all share the same properties. It's called attribute domains in the relational jargon, but basically it means that it all looks the same, like the same. Here it's an integer on the text. And anything that is in the table foo is going to have an integer on the text. That's it. All of them are the same. That's what is a relation. So consistency is pretty important. Then the I for ACID is isolation. It's the other side of atomicity. It's a little more complex to understand sometimes. But isolation means that while you are doing your queries, are you allowed to see what is happening concurrently in the rest of the system? So if you want to take a consistent backup, for example, you need to make it so that even if pgdump is going to run for several hours because you have terabytes of data, it needs to be a consistent snapshot of the production, right? So if during the backup, someone else is doing insert and updates and something else, you don't want those to be in the backup because you want something consistent. You want a snapshot that doesn't move. You don't want to see everything that's new. So pgdump will typically use an isolation mode where you don't see the changes from the other transactions. You can also do that in your application. And maybe it could be the default, repeatable read, or even serializable, it's different. But repeatable read might be what you expect from the database, but it's not the default. The default is read committed. So maybe you want to look into that. But anyway, every transaction in Postgres can have a different isolation level. ptdump will be serializable, while the rest of the system is repeatable read or read committed, depending. By default, again, read committed. So that's the isolation. So you see that's very important. That's very hard to implement at the application level. And so maybe that's why you're using PostgreSQL, actually. And then, of course, it's durable. So do you know the little test to do with the power socket plug? So basically, you write a little client application that will only do inserts, for example. And you count how many times you got the commit message back from Postgres. Remember that when you say commit, maybe the answer is going to be rollback, okay? Because there was a problem. PostgreSQL was not in a position where it could actually implement the commit. Like file system is full is the easiest example to have in mind. So you say commit, maybe it's rollback. So you count how many times when you said commit, it was committed actually. And then while the test is running, you unplug the power socket from the server in the middle of the test. And then you plug again, and you count what you have on the server and what you have on the client. If it's not the same, there is a bug somewhere. It's not durable. Durability means that anything that has been known to be committed by the client should be still there when you do that. If it's not, maybe the hardware is faulty, maybe the BIOS configuration, or maybe the kernel OS configuration is wrong. Maybe you did fsync off in PostgreSQL, or maybe you're not using PostgreSQL, and then, yeah, don't do that. So, yeah. So that's the basics around why would you use PostgreSQL. So to recap, because you have transactions, and transactions is a short way to say you are compliant with ACID. But be careful, because some systems are naming themselves databases nowadays, like those NoSQL systems in particular, where as a developer, if you think about them as databases, you might be in trouble because they're not as ACID compliant. All of the NoSQL systems that you will find are going to implement some trade-offs. The only that is obvious is that they are not implementing SQL. It's NoSQL. Okay. But also, they don't implement ACID usually. Take MongoDB, for example. It's a schemaless. That's a feature. It means do you not have consistency, so you lose the C of ACID. It doesn't have transactions, so you don't have the A nor the I of ACID. No atomicity, no isolation. Remains the D of ACID, durability. It used to not implement that. Apparently, they fix it nowadays, but for a long time, you wouldn't have the D of ACID. So maybe it's fine to use it anyway in your application because it fits your use case. But as a developer, if you think of a database or something that is ACID compliant, because that's how we are taught about databases usually, and the system you use is actually not ACID compliant, it means that all of those guarantees that you don't have, either you don't need them, that's cool, or if you need them, you need to implement them yourself. So that's, for me, the main kicker of using PostgreSQL is that you get everything for free, and it just works, and it's reliable, and you can just care about the application. And other good reasons to use it are written there, and we're going to see about them. So it's we're going to see about why I say it's object-oriented. We have extension in PostgreSQL. We're going to see a couple examples. Rich data types. You can do actually data processing in SQL, and we're going to see what I mean with that, and et cetera, et cetera. Any questions so far? No, maybe not. Okay. So who likes writing SQL? And think SQL is, yeah, nice, because we're going to see some of it. The rest of the talk is basically SQL queries in the slides. So let's go for it. And so as a developer, that's the main thing you do with PostgreSQL, right? Because it's ACID, so you don't have to care about that. So what you need to care about is implementing your business in the application. So you do SQL. Here is a very simple use case that I found because the data was open data at the time, but it's not easy to download anymore. The links have changed, and there is a subscription. I need to change the example later, but I didn't do that yet. So when you download the data, you have a CSV file that looks like this with the year, the date, the number of shares exchanged on the stock exchange that day, the number of trades that exchange those shares, and the amount in dollars that represent. And what you can see here is that I'm picking text as the data type for those columns, where maybe, obviously it's numeric, it's money, so it's numbers, but it's with a comma separate. There is a comma to separate the thousands. There is a dollar sign. So if you just say to PostgreSQL, hey, it's numbers, it will be not happy with that. Then we use copy on the client side, so the backslash copy, it's because it runs in PSQL. And so the file, the source file, is going to be required on the client side of the connection. So you can actually use that over a connection to a server. You don't need to upload the file to the server before you do that. So that's why it's a backslash copy rather than copy. And copy is actually not just a command in Postgres, it's also a protocol. It's a streaming protocol. So if you have a huge set of data, it's going to be streamed. So that's pretty fast, pretty efficient. And also, if you write your application code in Python or Java or something, as soon as you have more than a couple lines to insert into the database in the same table, you should use copy. Okay, it's way faster. Even for like the threshold I usually have in mind is like 10 lines. If you're uploading 10 lines of data into the same table, use copy. And it's available from it's a protocol that is implemented in your driver already. So just use copy from the driver. But then we don't want to use text. We want to use integers and numeric. Because it's money here, you use numeric, right? You knew that, right? You don't use float for money. Otherwise, you lose money. So don't do it. And the thing that I wanted to show you here is who knew that you can do in a single SQL command that is going to make a single table rewrite, you can actually alter 3 different columns in the same statement and use text processing functions to transform the data and make it suitable for the new data type. Who knew you could do that? Yeah. So another way to do it would have been for me to use copy from program, and you could run like a sed or hawk or Python filter to filter the data out and make it look like what PostgreSQL is going to expect. But if I had done that, then I couldn't have shown you that you can do it in a single statement, the 3 columns at a time alter table. Okay? Something that many developers have been told when I was consultant, or even now when I do meetups and things like that, that many application developers, they don't like SQL because it's a black box, and they're like, yeah, but we don't even know the algorithm that is going to be used, right? We write a query, and what is going to happen on the server, nobody knows, so we prefer to write the code our own way. So here is an example on top of the data we saw already. It's the list of the 10 days in the data set where you have the most dollars exchanged that day in the New York Stock Exchange, okay? So it's a top 10, it's easy, right? So you run through the data, and at the end of it, you sort the data, and at the end of it, you just output the top 10 lines. When you have to write that so the example is in Python here. When you want to write that in Python, maybe if you have like a couple of million lines in the database, maybe you don't want to have all that in memory at the same time, because all you want at the end is the top 10. So the number of lines you want in memory at any time is 10, not 2 millions, not 2 billion. So to do that in Python, you use heapq, and there is an API, like you heapify the list of 10, and then you heap push pop, and it will, if it's greater than what you have already, it replaces an entry, and if not, it's not included. That's it. And at the end of it, so this data structure is going to be worth of 10 lines for the whole processing of your script. So that's easy to control, and it's nice, okay? How do you do that in Postgres? Well, order by limit 10, that's it. Maybe it's simpler, I don't know. I don't know what you think, but if I had to write and maintain this or this, I think I would do the SQL version. But then the question I have is, how do you know that this guy here is going to actually be using the same thinking we did before, only 10 lines in memory at all time, rather than using all the memory for all the rows. And if you have 1 billion rows, it's a problem. So how do you figure that out in Postgres? Well, you use explain. My favorite variant of explain is using analyze, verbose, and buffers options, because that's where you have the most information. You need to be careful, though, because analyze will actually run the query. So if you have, for example, an update that is slow because of a foreign key that doesn't have an index or things like that, it happens, and you want to explain the update, you can explain an update. Maybe you want to begin, explain, analyze the update, and then roll back so that the update didn't happen when you work around it. So explain, analyze is running the query. And what do we see here? Sort method, top n heap sort, using this amount of memory. I think we covered. PostgreSQL implements exactly the same algorithm as what we did manually in Python before. So rather than writing all the code that is doing exactly that, but client-side, which means you need to fetch 2 million lines before you do anything, and then you sort them out. Maybe you can sort them out and send only 10 lines to the client, and it's way faster and way more efficient. And it's only 4 lines of SQL. Yes, question? Yes.
Maybe out of this context, but in SQL Server you get a hint, like if you're using multiple indexes and the query is running slow, it will give you a hint that use this kind of index.
Okay, so I'll repeat the question for the mic. Some other systems like SQL Server are going to give you hints about maybe where you should look at because the query is not as fast as you expected it to be. PostgreSQL itself will not do that, but we have several open source tooling around it, like a website called explain.depêche.com or PEV, which is a visual explain tool that will do that for you. So you will have a big red, one of those lines will be in red, splashy, and that's where you should focus. You have actually all the information you need if you know how to read it. But it takes some practice, so using something visual to get there is a good use of your time. Other questions? Okay, I'll continue then. Usually when you have this kind of data and you're working in an application in a team, one of the first things people are going to ask you, either the marketing department or maybe the finance department or maybe accountants, I don't know. Some of your colleagues are going to be interested into some kind of monthly reports. So how do you write a monthly report in SQL? It's pretty easy. Here I'm showing off several things, like I'm using pSQL in that example, and the set command is setting a value to a variable in pSQL, and then I can use the variable value here. So whatever the month is, I can change that and just run the same query again and again. And I can also pass the value of that at the command line of the script, at the pSQL command line, rather than in the file itself. So just so you know. And then we're using #, to do some pretty formatting. And then, oh, that's something you should pay attention to. We don't use between for the date. Do you know why? I could have said between start and end. But I don't do that because between is going to be inclusive for both the start and the end, which means that your monthly report, here I say the last day is the first day plus 1 month, and PostgreSQL will figure that out. Remember I told you it's object-oriented. Plus, if it's 2 integers, the result is an integer, or maybe a big int. If it's a date and an interval, then it's something completely different, but it's still a plus that you're using. It's like operator overloading in C++, except that it's very simple to use, and it just works. And so interval 1 month, because it's attached to a date, then PostgreSQL will look up into the calendar and decide how many days that month was. Of course, the example I've picked is February. So it will have to decide how many days you had that year in February. But PostgreSQL can do that for you. And then if you use between and this kind of expression, then you might count March the 1st twice, once in your February report and once in your March report. So that's a bug. And then you have the accountants running to you and trying to explain the data with you because they will never have the same result as you have. And you're like, I don't understand your problem. And you're okay, that's a bug here. So you use greater than or equal and less than strict. And you don't have that bug. So that's a small trick. Maybe you knew about it already, but I've run through many developers enough that I would, take some time on it. So here is the result without surprise. Okay, it's some data that we don't know the numbers, so we don't focus on them, but there is a bug. Can you spot the bug? It's missing days, exactly. Congrats. So we have 28 days that year in February, but only 19 rows output. Maybe marketing department or accounting, I don't know, won't be very happy with that. Maybe they want to have the days without activity. So let's fix it. It's easy. You run the same query, right? And then you do a lookup in the calendar in your application. Here it's in Python, but it could be anything else. And if the day is if the day of the calendar has some data associated with it, then you output that data, but otherwise you output zeros, okay? And here is the result, fixed. Well, is it really? So where is that code going to be used, actually? So maybe it's only used in one place, and okay, it's fixed, good enough. But maybe you have an application with different kind of people using it, like front-end people, back-office people. Maybe you have a little thing starting in the finance department that was, a quick PHP script where your backend used to be in Java and now it's rewritten in Django or things, real life happens. So maybe it's not that easy to say to everybody, hey, just use the calendar lookup, because mostly what happens is that the calendar default implementation in Python is going to be surprisingly different from the one in Java. Maybe because of the way they handle the default time zone. And maybe you have some other bugs. I don't know. It can get pretty complex. But the thing that is common for all of those is they're talking to our beloved PostgreSQL database. So maybe you want to solve the days with no activity in SQL. So who think they know how to implement that in SQL? Like, just a gut feeling. Okay. So let's see. There is one thing in PostgreSQL that is very useful. It's called generate series. And as I said before, we like boring names in PostgreSQL. So can you guess what generate series is going to do? It's going to generate a series. Okay. And it's going to begin with the first date, and then it's going to go up to the next date, but it's inclusive, like between is. So we say we go up to 1 month plus 1 month minus 1 day, so that we don't step over to the next month, because that would be a problem. And we do that 1 day at a time. We step 1 day. It could be 1 hour, it could be 13 hours if that's your business requirement, but here it's 1 day at a time. Okay, that's easy. So we generate a series of dates. That's our calendar. And then we do a left join. For each day of the calendar, we're going to look if we have data or not in the main table. That's easy. That's exactly the lookup that was implemented in Python before. It's exactly the same thing, but it's done with PostgreSQL on the database side. So we generate some values here, and we do a left join, and here is the result, fixed in SQL. Easy, right? And then the next question arises. Yes, question.
So for the left join rows that don't have the records, it's 0 all because you use a place there actually.
Yeah, I use Koalis. Good question. So the question is about how come you have zeros here? Where does that come from? Because it didn't exist in the data set. So we invented zeros. We didn't have any data. Left join is going to provide you with nil values. And Koalis is going to say, to take the first argument of the function here that is not null. Yes?
Next question is, in SQL we use place, like we can have 3 values, it will say first, second, or third.
So
This is pretty much using is null and SQL. This is how we use it.
yeah, so the question is about using Koalis or isNull or NVL or some other spellings of it. I encourage you to look at Postgres documentation to have more details about it. But here, Koalis is going to return the first argument that is not null. And you can have as many as you want.
But let's say if I want to check for -1, and then if there is a minus,
Yeah, then you use a case expression or a if null expression or something else.
so I cannot use place in that.
It's going to be too long for this talk, so let's have a chat about it later. Yeah, and meanwhile, have a look at the documentation. It's pretty well covered. It's something that in some communities, when you tell people, yeah, go look at the documentation, maybe it's a little rude to do that. The RTFM situation. Yeah. In our case, we take pride in the PostgreSQL documentation that it's being very well maintained. So if you do a patch for PostgreSQL that is technically very good, like something awesome, but not documented, it's going to be rejected. Okay? Any patch that goes to PostgreSQL needs to maintain the documentation that goes with it in the same patch. So we are very proud of our documentation system. So when we say, please read the docs, it's because we've been spending time writing it the good way, we think, and we would be happy that it's useful. So in the Postgres community, it's polite, so don't take it the wrong way. And so here is the result, and it's fixed. And usually the next step for marketing is going to be, okay, I want like week-on-week evolution as a percentage in the same result set. So that is a copy-paste from the result, because it's easier to explain it that way. And I've tried to change some colors. There is a color code. So basically, you want from this Wednesday, I think it's a Wednesday, it's a Monday, so the Wednesday is here. You want to know that it was 10% less dollars exchanged than the previous Wednesday. Okay? You understand the result set? It's just a percentage of difference with the previous day of the previous week, same day a week before. So who knows how to implement that in SQL? Okay, the others, I think you don't know SQL. I'm sorry. We'll get back to that. It's a strong statement, I know. So to implement it, we use a CTE here, and on the left, maybe you recognize it. It's exactly the same query as before, right? The generate series with the left join and the lookup. Oh, there is a little different. Let's get back to that later. So we compute that, and we use computed data here as a from clause for the next part of the query. And we compute the difference of dollars between the dollars from last week and the dollars from this week. But how do we get those dollars from last week? It's because we use window functions. And window functions allows us in one query. So the projection operator, the select clause is a projection operator. It works one row at a time, right? And here we want to see the values from another row. So we are going to say it's a peer row, a friend. So we have many friends now. And with window functions, we can go and see the other values from our friends' rows. And whose are going to be our friends here? Well, it depends on the clause you put in the over clause. So partition by and order by. Partition by, you can think about it a little like group by. So it's going to say, our friends are going to be the other rows who have the same value as us for the partition by clause. So we partition by extract ISO-DOW from date. ISO-DOW, know what it means? DOW, it's day of week. And of course, in some countries, Sunday is one, the first. Some other countries, it's Monday. And then in some countries, we begin at 0, not at 1. So Sunday is 0, Monday is 1. And well, it's crazy. So of course, there is an ISO standard about it. So we use the ISO definition for the day of week. And so anything that is a Wednesday is going to be 3. And anything that is 3 is going to be rows that we are allowed to see from the current one. So we're going to be able to see any row that has the same day of week as the current row. And we are going to see them in an order that we specify by date. And we're going to lag of 1. So we're going to be able to see the one that is 1 week before us. Question?
Is there a reason that you're using a tochar as in the select clause, but then in the window function you're using extract ISO-DOW?
Where is the?
So you have the
the tochar
as day, and then in the window function you're using.
Yeah, because the tochar here with the dy is going to be like Wednesday, or maybe using the locally that you have on your computer, etc. And this is a number, so maybe it's easier to reason about numbers in that clause. And also, those queries are for slides and showing off things. And so that's window function. So who's been using window functions before? Nice. It was invented in 92, like, around UTF-8 and maybe IPv6, like things that everybody uses every day. Nowadays, no, maybe not. But so that's SQL from 92. So if you are not comfortable with it and it's 2019, maybe it's time to learn SQL again. So the copy-paste from the result of the query is what we saw before. And the SQL standard, the current version is 2016, and any new version of the standard is deprecating every previous one. So there is only one current version of the SQL standard. So 92 is only interesting for historic purposes. If you do historic research, that's very interesting. If you do production databases or application development, you don't care about that. The only one that you care about currently is 2016. So how to think in SQL? Because what I'm trying to convey here is that SQL is powerful, and maybe you should be doing more SQL and less application code. Or maybe you should consider that part of your application code is actually going to be written in SQL. And the goal of this talk is so that we realize what is possible to do in SQL. And then there is the question of, is it advisable that you would do it as much of the implementation in SQL as I'm going to show you, but the answer to that is more complex and requires more understanding of the company dynamics and the skill levels of the developers and things like that. So I'm not going to answer that. I'm just going to try and show you how far you can go in SQL. So how to think in SQL? SQL is a structured query language. It's declarative, which means that in most programming languages, it's imperative or object-oriented, but it's still imperative. What you do is, when you have a problem, you think hard about how to reach to a solution, and then you write the code that is implementing what you think is going to be the solution. And usually when there is a bug, it's because your thinking was wrong, and what you thought would be the solution is actually not the solution. Okay. Declarative programming language is different. You explain to the computer the result that you want, so the problem you have, not so much the solution. So when you do SQL queries, you need to be able to think in terms of what is the problem I want to solve. And you need to explain to PostgreSQL the result set you are interested into. Not how to build it, but what it is. You need to define the result set. That's what you do in SQL. So that's why I think for SQL beginners, it's a little weird and strange and not very easy to do, but as everything, the more you practice, and the easier it gets. So. Another useful tip, I think, for thinking in SQL is Unix says everything is a file. So if you want to print something on the printer, you just cut your file to the printer device, and some pages are getting out. If you want to talk to the network, like connect to a network, you just open a socket file, and then you write to a file, and it's actually a socket, and it goes to the network. Everything is a file. Java says everything is an object, and actually the first chapter is some other data types, and the second chapter is object. So I don't know. So, like integers are not objects, but everything is an object. In Python, you have many things to think about and tools to work with, and in SQL you have relations. So what is it, a SQL relation? It's basically a collection of data that all share the same query attributes domains, which means a given number of columns, and each column is of a known data type, and every row for this column will have the same data type implemented in it. That's a relation. And any SQL that you are going to write is going to define a new relation based on other relations. So when you're writing SQL, you're composing relations to build another one. And so the from clause, for example, introduces relations, which is why you could use a subquery in a from clause, because a query is defining a relation. And of course, you can select from any relation, including a subquery, right? So thinking in SQL means understanding relations and how to play with them and compose them. And to compose them, you can use joins or set operators like union, except, and intersect. And in terms of join, we have inner and outer join, cross join, natural join. It's all, some of them are syntax differences, some of them are semantically very different. We even have lateral joins. Who's good with lateral joins? Again, that's something quite new in SQL, but it's part of the tool set that you have. So if you don't know what it is, maybe sometimes you will need it. And rather than writing a very efficient query that then you can just, use the result of, you're going to have to implement it in your application code and retrieve so many data when you need it only that much. So here is an example with a lateral join. And I try to put in bold the keywords that are related to the relation concept. So with is a CT common table expression. It introduces a new relation that you can reuse later in the query. Select is the projection operator. Oh, by the way, this query is based on a Formula One database with all the races and the drivers and the results. And it's going to give you the top 3 pilots in number of points that they accumulated in a season, but by decade. Let's see the result. So in the 50s, it was Fangio. So if someone told you that you're driving like a Fangio, it's a common French thing to say. Some people take it as a compliment because he was number 1, but he's also the guy who broke the most number of cars to get there. So I don't know. And maybe you can see we had French guy there, Prost, and then Schumacher, of course, and etc. So for each decade, the 50s, the 60s, 70s, etc., you have the top 3 drivers. And that's where you use a lateral join, because you can have a subquery, and you can inject things into the subquery thanks to it being on the lateral side of a join. And then, so you inject a where clause that comes from the decade, and then you can group by and limit to get the top 3 of them. So it's currently the best way to write a top n query, usually lateral join. So when you don't have it, it's very complex to write. When you know about it, it's like, oh, I know how to do it, done. Okay. Any questions so far? You can interrupt me whenever you want to. So let's continue. What I'm trying to say now is that SQL is code. So if it's code, maybe you need some tooling that is going to look like what you have usually when you write code. I've put the SQL query here, again, just for perspective. My rule is that if the query fits on a slide, it's a simple query, right? Well, okay, in that case, I had to use a very small font that nobody can read. So maybe it's not simple enough, but it's the kind of queries you're going to write. And oh, something I didn't say before. What is that? A command, because SQL is code. So of course you have commands. Maybe your colleagues, they don't know generate series. They've never seen that. So if you use that, and then you have, of course you have a review process. You don't push code directly to production, right? So someone is going to have to review your code, and they never seen a generate series before. And they're going to say, no, I don't want to accept this. It's foreign to me. I don't understand it. It's going to be impossible to maintain in the future. Please do it in Python or anything. So you add a nice comment to your colleague, and he's going to be like, oh, that's very nice. I didn't know that. Thank you. So, you know, comments, of course. And then what you can do with integrating SQL into your application code is, the best way to do it that I found is that you actually use .SQL files, because then you have syntax highlighting. It's actually code. The day you have a problem in production with queries, then you can just, you know, send a link to your, maybe you have a Git front end like GitLab or GitHub or something. You send a link to the DBA, and it's going to copy paste the query, play around it, and then send you a PR that fixes the query. Because it's just a SQL file. That's what we do, right? If you're not doing it that way, maybe you're losing out on some of the process around SQL in your code. I don't know. And so how to do that, we are going to see about that. And maybe you want also unit and regression testing around the queries. So let's see about that. For you guys who are using an ORM in your code, I'm running short on time, so I will not explain more about it, but just don't do it. It's not worth it. Do that instead. So those projects began with a Clojure implementation. It's called SQL. And basically, it looks like this. You write queries in a SQL file and with some comments, and it's going to expose the query here. You load the queries, and then all the queries are going to be exposed as function calls. And the result is going to be native objects in your programming language. Okay? So the integration in the code is going to be so easy. And also the query is just a SQL file that you are able to share very easily with your DBA friends, because now they're friends, because it's easy for you to work with them. And also to review when you do code reviews. I'm running short of time, so I think questions are going to be after the talk. I'm sorry about that. And then you can implement regression testing on top of it. So I wrote PostgreSQL in Go because I wanted to see if I did like Go or not. But it took me like, I think it was less than a day. So if you want to have the same thing in Java, Python, Ruby, whatever you're using, my guess is it's going to take you maximum 2 days to get it. So don't focus too much on this implementation. The idea is very simple. You have the SQL file. Those are files in your file system, right, in your code, as we saw just before. And so what you do is you create query plans, like you associate for each query some parameters. And then you run the queries, and you keep the result of them as an out file, like copy from the query, and that's a CSV file. You store that. That's the expected result. And then when you change the query, you run the tests again, and you compare the output, the current output, with what you expected. That's unit testing, right? It's very simple. You do a diff in between the two files, and you know if there is something that changed. So when your DBA is providing you with an optimized version of a query, well, you integrate it into your system, and you run the regression test, and you know if it's still behaving exactly as before, or maybe not. So it's easy to do. And so that's the main parts of the presentation about SQL and why I think that SQL is code and how you make it so that actually in your development process, SQL is code. And then before we wrap up, I wanted to show you some powerful queries that you can do with a PostgreSQL extension. Because up to now, it was maybe not so much boring, but not very, I didn't see much sparkles. So maybe I can do that. First query is going to be geolocation. Maybe you know about Geolite. They provide you with a data set of like, geolocation is easy. You have in input an IP address, and in output you have a location on Earth. But then you need someone to collect all those things. And MaxMind is the company behind Geolite, and they say that you can use it for free as soon as, or as long as you say where it comes from. So I just did, so I can use it for free. So Geolite, yeah, that's the license. So yeah, so that's Geolite, and you have a location ID, and you have two tables with the things. And here we use an IP range. So it's provided as the data type that is provided. IP4R is an extension that you can find easily, and it provides you with IP ranges of addresses. And this operator, maybe you don't know how to read it yet, but think about it. The first time you saw this equal operator, you didn't know how to read it either, so you need to learn about that. So this one reads contains, so the IP range contains this address. That's easy. And also we can have, with PostgreSQL, we can have exclusion constraints. So you can build your blocks table in a way that you guarantee that any range has no overlapping range anywhere else in the table. So when you give it one IP address in the lookup, you're going to look up either 0 or 1 answer. That's it, because there is no overlapping, okay? And PostgreSQL is going to guarantee that, which means that now you can write this query, which normally wouldn't pass code review, but I didn't comment on that because I wanted it to fit in the slide, okay? Sorry about that. But here there is a comma, which means it's a cross join. Don't do that, never. But we have the guarantee that this geolog table relation, the result of this query, is going to be 0 or 1 row. It's a strong guarantee because we have the constraint, okay? So the cross join is going to be against 0 and 1 row, so maybe it's okay. And I was lazy, so that's the way I did it. And then we have an order by, limit 10. It's called the KNN. K here is 10, okay? Q is 10. And then we're going to have the 10 closest rows. And that's the IP address of a previous conference for PostgreSQL that happened to be in Dublin. And that was the 10 pubs nearby the conference center. Because you talk for an hour and then you're thirsty, that's what happens. So, and it's a very simple query. So if you want to implement geolocation into your application, maybe it's like a 10-line query to implement it. It's like, I don't know, half an hour of work and done. Well, I don't do the visuals and the mapping, so you do that, but yeah, you have the query. That's easy. I'm running out of time, so this one was interesting. It was bashing on MongoDB, but so anyway, you'll have the slide, go read over them. And this one is, I don't have time to explain it, but it's a model view controller in a single SQL query, and the result of the query, copy-pasted from the console, right, is that. So that's the kind of thing you can do with SQL and Postgres. Any questions? No? So I'm going to be at the booth later, so if you have questions that come up in your head later, please just show up there. And that's it.